Hello, welcome back. This is Logic Coding. Today we're going to look at two word break problems. The first is a medium, the second is a hard. So the first medium, we are given a string and a dictionary of string word dict, and we want to return true if S can be segmented into space-separated sequence of one or more dictionary words. So what does this mean? Is if we have a string and we have some word dictionary, we return true if we can segment this string into words. And note that the same word in the dictionary can be reused multiple times in the segmentation. So if we have a Leetcode and we can segment into Leetcode, so return true. If we have Leetcode Leet, and since Leet is again in this, it can be used twice. Second example, if we have apple, pen, and apple, of course it will return true as well, since we can segment into words in this words dictionary. The last example is cat, sand, or cat, dog. So if we do cats, we would have and dog. So we find out no matter where we do the segmentation, we cannot segment the whole string into words. So how are we going to approach this? So we know the input, we know the output, and how are we going to do this? So if we found it, for this one, I think we can definitely do a dynamic programming where DP means true or false, which means up to index I, can we, or up to length I, can we do segmentation? So how can we update this DP then? So DPI will equal to true if we can find DPJ, which is true, like DPJ which is true, and the substring from J to I, like inclusive, is in word dict. So under this part, we see that we need to have an operation to judge whether a substring is in this word dict. So we better use an unordered set, which will support constant operation to check whether it does consist of the word. And we will just return dpn at the end. So in this algorithm, the time complexity will just be O(n) squared, because we will have two nested for loop, and the space complexity will be O(n). Within that, let's try to code it up. Let's first get the string.length, and we know that if actually we don't need to consider n equal to 0 for now, and then I will associate a Boolean vector for my DP array whose size will be n plus 1. At the beginning it will be false, but DP0, which means length, when there is no word, will equal to true, and at the end I'll just return dpn. So how can we update dpi? Outer loop will be for int I equals to 1, I greater equal to n, I plus plus. The inner loop will be for int j equals to 0, j smaller than I, j plus plus. If we find a dpj which equals to true and s.substring came from this j, and the length will be I minus j, because when j equal to 0, I can go up to n, so the length will be n. And I have, okay, so first let me convert my word dict to a set. to an unordered set such that this operation will be constant time. And this substring is in my set. Then I can say, okay, my DPI will equal to true, and I just break from this. Once my DPI equal to true, I'll just do break. Let me submit it. Cool, seems to be working. And that's pretty much about it. This is like a classical DP. So for DP problem, we have three ways. We have prefix, in which case this is a prefix. The I depend on whatever goes before that. We have a suffix, which I depend on I plus 1, I plus 2 come after that. And we have substring. Substring is for dealing with like palindrome or palindrome, basically. But I will be making videos regarding to all those questions in the near future. So that's pretty much about it. Whenever we met such a DP problem, the first thing is to reduce it to something that we're familiar with, write out the pseudocode, analyze the time and space complexity, and then do the implementation. That's it for today. Thanks you guys for watching. I'll see you next time.